Good morning. We are moving on to lesson 10.3, misleading graphs and statistics. So, graphs are sometimes misleading in their representations, and they can influence conclusions by misrepresenting the data. So this happens a lot in commercials, right? When they're comparing two kind of brands or something, and they want you to, like their brand more than this other brand. They'll show you the true statistics. They'll be, honest. However, their graphs or their visuals will be misleading. And I think a lot of us, hopefully not, this class, but a lot of us are not looking at numbers. We're looking at the pictures. And when we look at the pictures and we see something drastically different from one to the other, well, then we're going to focus on that, and our conclusion is going to be based on what we see, right? But not the math behind it. So today we're going to be looking at types of graphs, right? And identifying why they might be misleading. What are they doing? What are they trying to get you to think? And who might they be kind of influencing, right, with these graphs and statistics. So we're going to start with graphs, then we're going to move on to statistics. So let's look at these two graphs. Graph A, graph B. Don't look at the math yet, just look at the visuals, right? So graph B, the bars are higher, and I know that the bars are representing price, so I'm thinking that I do not want to go to graph B, right? That's spring dance. Because if those are the costs of tickets, geez, oh Pete's, they were expensive, right? So I'd rather do the first spring dance, that maybe venue compared to the other one. However, let's look at the math now. So my x-axis for both of them are the exact same. However, my y-axis, which is price, that's where the numbers differ. So graph A, 0 to 4 to 8, 12, and 16. So we're counting by 4s there. Graph B, we are counting by 2s. Okay, so let's look at each individual year. So 06. Both of them have a price of $4. 07. Looks like they're both staying at $4. 08. Let's see. Looks like they're both about $5. 09. $6. 010, or sorry, just 10. $8. So it turns out that they are the exact same graphs, right? Or they're representing the same data, but they're not the same graphs. So who might they be kind of broadcasting this to? If this were a student council and they were trying to, advertise their dance, which one would they use to advertise the dance that they're planning? Well, they would use graph A, right? Because just visually, it looks like it's less expensive for that dance. If they wanted to say, or if they wanted to kind of show a competitor for some reason, or I don't know, they would use graph B, right? Even though they're the exact same thing. And neither of them are wrong, right? This is the issue. Yes, graph B, or compared to graph A, they're misleading. But technically, nothing's wrong with them because they're showing correct, accurate information. But it's just how they set it up that to the general public, it looks like a drastic difference. Again, people are more visual, picture-oriented. They're not going to look at the numbers behind it. So the questions you need to ask yourself, kind of which shows a steeper increase in price. So tonight for your homework, you're going to have to talk through, like we just did. If we were talking about student council, which one would they present? and why. What's the difference between those two? How are they the same, but why are they looking different? What's the goal in the difference? So that's graphs, right? And each graph or chart or visual is going to be very similar to what we just did here. So we're going to move on to statistics. I'm kind of keeping this video a little bit short because it'll change depending on kind of the scenario, the situation. There are lots of different ways you could explain it. So let's move on to statistics. Statistics can also be used to influence conclusions. Now again, they're not wrong. So that's the big issue. It's not super wrong to say some things. It's just not the most representative, right? Conclusive. So when we think statistics, we need to think 3 words: mean, median, and mode. Now it's been a while since we've dealt with these, so let's kind of just practice and understand what they are. Let's refresh our brains. So mean is the average. So to find the average, we need to add up all of the numbers and divide by the number of numbers that we have. So I've already laid out the numbers that we're going to use here, and I've ordered them from least to greatest. So that's something important to keep in mind. So the mean, I'm going to do 2 plus 2 plus 3 plus 4 plus 6 plus 7 plus 19. So I get 43. And we have 1, 2, 3, 4, 5, 6, 7 numbers. So I'm going to do 43 divided by 7. And I get, let's see, 6.14. Alrighty. My median. Median, you need to line up our numbers in order from least to greatest, which I've already done. So I'm going to write them down here. And then we need to find the middle number. So I'm going to go right, left, left, right, right, left. 4 is our median. Alrighty, mode. Mode is the one that happens most often. The number that happens most often here is 2. Now, if there was only 1 2, you would just say there's no mode, and that's perfectly fine. Now, let's just kind of look at these statistics, mean, median, and mode. And let's look at our numbers. 2, 2, 3, 4, 6, 7, 19. Of these numbers, which do you think is the most representative of kind of the middle of these numbers? Do we think it's the mean, which is 6.14? And think if I had to write 6.14, that would be right between the 6 and the 7, right? So that's well above, 5 of the numbers. Mode, most often. 2, the smallest number. That's the lowest of all the numbers. But median in this case is actually that 4. And that's about right? I would choose the median to accurately represent this data. So I think the mean is a little high. I think the mode is low. I think the median is just right. Why do we think the mean was skewed? We think the mean was skewed because of this outlier, this 19, right? Every other number is about 1 or 2 steps away from each other, right? 2 to 3 is 1 step. 3 to 4 is 1 step. 4 to 6 is 2 steps. 6 to 7 is 1 step. But 7 to 19 jumps quite a few steps. So that 19 is really going to skew our data. If we chose to find the mean without the number 19, let's see, what would we get? So if I chose to do 2 plus 2 plus 3 plus 4 plus 6 plus 7, and I divided that by 6, our mean would end up being, divided by 6 would end up being 4. that mean is more accurate, right? That's the same as the median. But it's because of that 19, that outlier, it skewed our statistics. So let's look at this example over here. We're going to be asking the exact same things. So it says an amusement park boasts that, and boasts means brags about, the average height of their roller coasters being 170 feet. Explain how this might be misleading. Okay, so the statistics we need: mean, median, and mode. Now, here, the 170 represents the mean. It represents the mean because it says the average is 170. Average is the same thing as mean. Okay, well, let's order the numbers first from least to greatest for our medians. We've got 109, 115, 126, 135, and 365, right? 1, 2, 3, 4, 5. Okay. All right, so median is 126. All right, mode, we have no mode. But let's look at the mean. So 109, 115, 126, 135, and then 365. So they're saying their average of all 5 of those numbers is 170. That's probably true, right? So let's check it. 109 plus 115, 126, 135 plus 365. It is 170. Let's find it without the 365, because that 365 is definitely looking like an outlier, right? So let's do 109 plus 115 plus 126 plus 135. We'll divide that by 4. So if we choose to use these 4 numbers and find the mean, we would get 121.25. Okay, so that mean, 121.25, is pretty close to the median, 126. Is it accurate to say the average height of their roller coasters is 170? Yes. But 170 is well above the majority. So this one, this one, this one, and this one. It's above 4/5 of their roller coasters. So to say the average is 170, that's misleading, right? The tornado at 365 feet skews the statistics. So that 170 is misleading. It is not appropriate. A more appropriate statistic would be to use the median, because the median is 126. That is closer to all of the heights. It's closer to each of those 4 than it is to the 170, right? 170 is way beyond. So, questions we need to ask ourselves. Does the mean accurately represent the info? No. Does the mode? No. But does the median? Yes. So, the median would be a better representation of that data. So, go through the homework. Make sure you check my answer key before you submit it to Google Classroom, and let me know if you have any questions.